Hi, Dan, and welcome to our run through of our 507 project. Today we'll be discussing the project of replacing gantry cranes in the Boeing Skin and Spar facility with automated guided vehicles. We'll walk through our general project statement, go through different solutions that we identified for this, ultimately ending up with the AGV. Of course, we'll review the risks and mitigation strategies that come along with this implementation, who's impacted, and then what our analysis looks like in terms of total cost and timeline. I'll hand it over to Jason for an overview of the problem.
All right, the problem statement with the issue of gantry cranes for wing structure movement at Skin and Spar, Auburn, revolves around the issue of the crane safety envelope, with costing labor of up to 12 workers at any one time across 12 different work centers. Within the 2-year project timeline, we plan to determine and implement wing structure movement alternatives to the gantry cranes that will reduce lost labor hours while incurring equal or lower accident rates and long-term improvement. Our goal is to reduce billing. Oh, sorry about that. Billing 275 work days at a rate of $145 an hour, improve safety, and investments in new tooling and continued expenditures in maintenance. The impact currently, crane disruptions cost a little over $1 million in lost labor, and future gantry crane operating maintenance costs around $116,000 a year. This is at the current rate of 38 planes per month.
We have a few different success criteria that we will be measuring this project against. The first major two are tier 1 criteria. Those are earned hours and long-term investment. Earned hours is a productivity and efficiency measure. This looks at how much time it should take to produce one wing structure through the entire Skin and Spar facility. Right now, just about 140 hours per day when you sum up all the work completed at different work centers. And our goal is to keep that earned work under 10 hours. The long-term investment function is a measure of fiscal risk associated with the movement vehicle that moves the structure from work center to work center. Right now, the gantry crane takes about $116,000 every single year for upkeep. We'd like to keep that under $100,000. Our tier 2 criteria are still important, but just not as crucial as that earned hours rate and total operating costs. It's of course production rate, which Jason alluded to. That's the goal of throughput per month. Accident rate, so safety is a crucial component at Boeing. We want to make sure that there are minimal accidents, and so when moving to a new vehicle for the structures, we'd like to keep the same rate. And then cycle time and manufacturing cost per unit are two inputs to our tier 1 criteria, with cycle time being the actual time it takes to produce one one structure, and then the manufacturing cost per unit being the all-encompassing costs of materials, labor, and overhead for one wing structure. Within our solution, we looked at a few different options to reduce the crane safety envelope. Basically, with the gantry crane, we have a time and a half around the crane's height as the envelope that can't be operated in, as well as nothing under the wing structure itself. We wanted to reduce this safety envelope in order to increase the number of hours other work centers could work and be unburdened. We looked at jib cranes, but unfortunately still have that entry requirement underneath the load, or lack of entry underneath the load. And then we also looked at telehandler forklifts, but those are very accident prone and aren't really appropriate for this work setting. Ultimately, we landed on the AGVs, which have a smaller upkeep versus the gantry crane and a much smaller safety zone. For our final recommended solution, we leaned into the heavy duty unit load conveyor AGV, which is a mouthful. This specific type of AGV enables us to raise and lower the wing structure, as well as the conveyance on the actual AGV allows the structure to flow on and off any physical structures for tooling easier, and reduces the risk of damages as well as improves safety for any workers that are moving that structure on or off the conveyor.
All right, so this is an overhead diagram of our current factory floor. And if you look at the top diagram, so the red arrows represent all the current crane routes that are done multiple times per day with large pieces up to 120 feet in length. So based on the 30 feet envelope that surrounds anything that is in the air, the red bubbles represent all areas that must shut down and step aside as the crane passes. So with that, this is where we're getting all of our stalled labor, people standing around and waiting for things to move by before they can continue working on their project. So if we switch to AGVs, what this will do based on the ability to work much closer to an AGV, the berth is about 20 inches. AGVs can move in and out of existing passageways without disrupting the workers that are working on their other projects around, therefore saving us labor and making the overall floor much more productive and eliminating that need overall.
Did it skip that last one? Or did we skip that last one?
We did, sorry.
Oh, so just going over our math for our top 5 work centers of productivity loss. With our simulation program used at Boeing to map the crane usage based on other observations, there were about 56 occurrences leading to 4.26 hours of lost hour with each occurrence. And within those 5 work centers, 32 employees were working during that time, equating to a loss of 136 hours each day at our current rate of $145 per hour of lost time with 275 work days in a year. That's where we came up with the $1.007 million in lost labor. Our risk of assessment and mitigation strategies are based on 4 issues. The priority 1 is union pushback. Initially, there will be some resistance to adopting AGVs, but we do have contracted that the rate would grow with the workforce. So we're permitted to not hire as we go from rate 38 to 63. But one of the other considerations on number 4 is that is a time constraint is adopting this. As our rate grows, we need to have that in place so we don't have to hire to cover that. The other constraint we have is facility. This is an older building that wasn't built with this consideration, but with modern AGVs, we should be able to accommodate that. And then another issue that we're facing is our safety department, environmental safety and health, just needs to make sure that these are compliant with our current Boeing pros processes for safety.
Within all of those risks, we're also looking at our internal stakeholders that we want to keep in mind during this process. We have, of course, our customers who are downstream wing facilities. We are taking their inputs regarding their capacity and demand for production and directly including that into our implementation timeline. Will be an open stream back and forth to make sure that our timelines match theirs. Moving to the middle, our major stakeholders. These are really our partners that are working with us every single step of development in this project. from the first benchmarking study through debrief after it launches. Specifically within here is our finance team, who will be the approvers of CapEx expenditure in the AGVs. They will be most involved in initial studies and making that procurement effort happen, where of course we will be getting multiple quotes from different suppliers to ensure that we have the best possible costs there, and of course make our finance folks happy. The last one is our minor stakeholders. These are more stakeholders where we're listening to their feedback and keeping them informed, but they are not directly influencing this project. Goodness, there we go.
Integration with our IT systems there will be like a belt and suspender approach with this. Starting with our AGVs, we'll give up-to-date information throughout the fleet and up to the control system. Where it will ask permission to take actions from the control system. The control system sets the rules and parameters of each movement for the AGV fleet. Now on that, we'll also integrate a redundant human element from our Boeing Lightside Control Center. LSCC will monitor AGV movement and resolve any emergent issues.
So this is the NPV analysis that we did for this project. So if you see in year one, we'd be looking at about a $2 million input for 12 units. And immediately that same year, we would see about cost savings of about $81,000 in maintenance. And then we would see a proportionate labor savings based on the rate of airplanes. So at 38 airplanes per month, we're looking at about $1 million in annual estimated savings, and then that would increase proportionate to the rate as seen in year 2 through 5. That gives a full 10-year NPV of just under 11 million with a discount rate of 3.75%. And in the back, we do have the full NPV for the full 10 years if that's something you'd like to see. We did this for visual purposes. So thank you. And so this is our implementation plan. It's broken into 4 segments. The planning section would come first, obviously, as we would map out our floor and do some route planning. And we'd start planning for floor renovations. If we needed to move anything around as we prepared these routes, we would run simulations to see what the outcomes would be. Once we've got a good fix on that, we move to our sourcing portion. We're estimating this could take anywhere between 4 and 6 months, depending on the bid process. We run a standard source selection RFQ process, and once we reach a settlement, we would then drop POs and let the supplier build our AGVs for us. These are built to order, and some of these are long lead time parts. So estimating that this would take anywhere from 8 to 12 months for these to be ready for delivery. In that time, we would take advantage of our planning, and we would probably work the floor renovations to be ready for our delivery of our AGVs. And that brings us to the last section where we would have them delivered and installed. We would run all the testing we need. We would train our employees around them and with them to ensure safety and quality, and that it stays smooth. So the whole process, depending on lead time, we're looking at anywhere between 14 and 24 months from start to finish until we are operational running with these AGVs.
And with that, we'll look forward to your feedback and talking to you on Wednesday. Thank you.
Thanks, Dan.